Hey everyone, we are back with a hard question series. Do let me know your hard questions by dropping a mail to me. Even if you are looking for some hard questions, you're fed up of doing easy questions. Even if you go to the college board, you will not find that type of questions that you will see on SAT, at least one or two questions. Do watch our hard question series. Try to do each and every question. If you get stuck, I have told you some tricks how to solve it. Follow that. And also, I am taking these hard questions from different platforms where students are posting. Some of the hard questions I am taking, which has been repeated, a kind of pattern that was repeated in August SAT, September SAT, and it has a high chances to repeat in the upcoming SATs. So stay tuned, do subscribe the channel if you haven't, and do share it with your friends whoever is appearing or planning to ace SAT this year. Let's move forward. Today's hard question is gonna be 2 based on this one, quadratic. So here it is a higher degree of polynomial basically. Now, the first question is right here. It says, in the given expression, b is a positive integer if q raised to the power qz raised to the power 7 and plus r is a factor of an expression where q and r are positive integers, what is the greatest possible value of b? Take 30 seconds, pause the video, and try to understand the question. What is it asking? Now, let's get started. So, initially, we have done questions like that. If you have watched my most repeated question playlist, in that question, there was one question that was repeated, and we used to do like that. How, if there is one factor, there should be another factor as well. So, can I comment on discriminant? Yes, the discriminant should be greater than equals to 0, right? Now, if discriminant is greater than equals to 0, but here this is not a quadratic equation. Can I form this expression as a quadratic equation? Yes. How? I can assume z raised to the power 7 as x. So if z raised to the power 7 is x, I can rewrite my equation, my expression as 38 x raised to the power 2 plus bx plus 70. Now, from here, I can find out the value of b, a, and c and put it in this discriminant, right? So what it should be, a is 38, b is b only, and c is 70. So I can do 38 square minus 4 times a, sorry, my bad, b is b, so let it be b. Now this a is 38 times 70, right? What else I can do? I can write it down like this. B square is greater than equals to 4 times 38 times 70. Why am I not solving this? Because you will get the greater value. B is greater than equals to this. If in case in the question they are asking you to find out the smallest possible value, then it should be the same. You just solve it, multiply it, and find the square root of this number, and you will get the smallest possible value. But in the question here they are asking what is the greatest possible value of b. In that situation, in that type of question, we cannot apply this method. Now if we can't, what is the other method? We can compare, right? Simply, what you have to do, I know that if one factor is qx plus r, let's say the other factor is sx plus t. Why I took sx? Because in the first term is nothing but x square, right? So that's why you can take any other variable. You can take ax plus b, you can take mx plus n, right? But the thing is you have to take this n so that when you're multiplying the first terms, you will get x square. Okay, now understand the thing. You will simply expand it. So once you expand it, your equation, your expression looks like qs x square plus qtx plus sr or rsx plus rt. right? Now I'm going to compare this with my expression above. What is the coefficient of x square? It is 38, and here x square is qs. So can I say qs equals to 38? What is the coefficient? What is constant here? 70. And what is constant here? 7 rt. Can I say that rt equals 70? Now here, what is the coefficient of x? That is qt plus rs. So I can say qt plus rs equals b. Now in the question I have to find out the greatest possible value of b. So in that case, if I want to find greatest possible value, what I'll do, I'll take q as 38 and s as 1. I can take that, right? Because if you take q as 1, you might not get the possible greatest possible value. And here either you take r as 70, t as 1, or you take t as 70 and r as 1. Both will work, right? Let me take t as 70. Why am I not taking r as 70? That will also I'll tell you. Let's take r as 70 first. Okay, so when you're taking q and t, q is 38, r is 70 plus, sorry, here r is 70. Okay, my bad, let me erase it. It is qt, I thought it is qr. So t is 1. Here I'm doing 38 times 1 plus r is 70 plus s is 1, right? So when you are doing 38 times 1, it is 38 plus 70 times 1 is 70, and when you add them you will get 118, right? But you are not getting the largest value. What if I take t as 70? I will get the largest value. So q is 38, t is 70 plus r is 1, s is 1. Now when you multiply both of them, you will get 2660 plus 1, which is nothing but 2661, which is the highest possible value of p. That's why we consider r as 1 and t as 70. Understood? Now you don't have to do all this, you just have to think about it. Multiplication is more, will give you a bigger number rather than adding it. So like that we can figure out. I hope this question is good. Why are we not using that formula? That is also clear. And why are we using expanding for method and then comparing? I hope it makes sense. Do give me like and thumbs up so that I can understand that these are helpful for you. Now coming to the next question. The first thing, if you have solved and watched my previous videos, you will definitely tell me that I'm gonna plug in the values and check it on Desmos. Are you going to do so? I'm gonna plug in the value of b. I can take the value of b as any integer value. I can take b as 1, and then simply I'll plug in the value of b, and then I'll find out the answer. But here that is not the case. Let me show you. Whoever has not watched the most repeated videos, do watch those most repeated videos before directly coming to these hard questions series, because in that most of the techniques and the strategies have been shared, and once you do those you'll build that kind of mindset, and these hard questions you can easily grab it after that. So let me tell you, we can't plug in the value of b because here b is a part of the question, right? So even if you're doing using that quadratic formula, negative b plus minus b square minus 4ac in the radical divided by 2a, in that case, let's say here I'm using that formula, so it is going to be negative 9 plus 81 4ac divided by 2a. So in that case, you will get this answer in radical. Value will not be an integer, right? That's the reason why this question comes out to be the hard question. This is not a hard question. It is a question where the normal method doesn't work, and that is when most of the students get stuck. So let's try one standard method. if this is a factor, can I say when you divide, you can put, I can say that to x plus 2b equals to 0. What is x? X is nothing but negative 2b. Now x is negative 2b. Now what I can do, I can put it in the functions, in these expressions. In place of x, I can put negative 2b and I can check the values directly on Desmos. Let's do it. So my equation will look like this. Let me write it down here. It will look like 3 negative 2b whole square plus a negative 2b. It's not a, I guess it's 9. Okay, 9 minus 2b plus 18b. I plug in the values. Now directly I'll put it on Desmos. Let me do that. Desmos do not understand any other variable other than x and y, so I replace the value of b with x. Now, can you see your graph is only at 0. 0 is not an integer. I'll check the other values as well. Now all first term and last term is same in all the expressions. Only the middle term is changing. So 24, 30 and 39. First I'll put 24. 24. So here it is 0, but another value is decimal. It's not an integer. Then it was 30 and 39. Okay, let's put 30 now. No, no integer, only 0. 39. Okay, so you're getting 0 as well as 5. 5 is an integer, that's why the last value is correct. Okay, last option is correct. That's how we have to do this question. Make a note somewhere all the hard questions that we are discussing, so when your exams will be closed, these are going to be really helpful at the time of your exams. Okay, so that's all for today. Stay tuned. We will be back with another set of hard questions. Till then, take care and thank you.